Hello everyone, welcome back to Skill Talk. So in the previous video we understood about the absolute phase, relative phase and also the directional phase. So this video will be our third video on this our normal phase series. So now in this video, in our third video of phase, we will focus on that how phase is measured in the real life, especially when there is no tacho available. And also let's say we will be clearing some doubts when the data will look little bit confusing, or let's say that whatever the phase readings that you are getting, it's not making any sense, right? So what this video will help you to avoid wrong conclusions and build a confidence in the phase analysis. Okay, so normally most of the analysts, what they think that if there is no tacho, then there is no phase, especially the guys who has just now started learning about the vibration. So normally whenever they hear the name of phase, so what they think, we need one tacho and one sensor, then only we can have the phase, so but actually it's not true, and because phase can be also measured in the absolute way, right, without a tacho. So here we must understand that what type of phase you are measuring. Okay, so overall the thing is this, that without a tacho, yes, you are not measuring the absolute phase. Okay, and you are measuring a relative phase. If you are having if you are not having the tacho with you, then definitely you are measuring the relative phase, and if you are having the tacho, then it's a absolute phase. So just remember this thing. Already we have discussed. If any confusion is there regarding this, please go and watch our last video, that is the on the phase analysis video 2, right? So now let's move to the next. Now what this dual channel phase means, right? It means that we are comparing two vibration signals which are vibrating at same frequency. Okay, so this is a very important thing. Remember that the two vibration signals at same frequency, or you can say the same RPM. So let's take an example. Let's say you are comparing inboard and output bearing, or let's say motor or pump, or horizontal or axial, whatever kind of that you are measuring the phase difference by using the two sensors. So always remember that the frequency should be same. So here let's say that the analyzer compares the timing of signal A and signal B, and what will happen, that they will calculate the phase difference between them. Okay, so what are the important thing that we have to remember? That same running speed, or you can say the same frequency, right? Or always it's very important to remember this thing. Otherwise what will happen, that you will be making a very wrong conclusion, because it's very important that whenever you are using two sensors, and it's always important that the frequency of that particular two locations or two places or that particular equipment should be same. Okay, now let's clear a few more important confusions. So always remember that we have already discussed in few of our last videos, that always remember that spectrum always tells you that what frequency exists, right? Okay, and that what the time waveform will do, time waveform will show that how vibration is changing in accordance with the time. Remember, and the third thing that is very important, the phase always tell us the exact timing difference in degrees. Always remember this thing, right? So what phase tell us? Phase tell us that exact timing difference in degrees. So if I want to express in the simple words, what I will say, that phase is waveform timing expressed in degrees, right? So if you understand the waveform, definitely you will be understanding the phase. So now let's talk about the biggest cause of the wrong phase interpretation, that is the sensor orientation errors, right? So what common mistakes that we are making especially in the sensor orientation, that let's say that you are using a very long cables. One is you have mounted to the drive-in bearing, and another to the non-drive-in bearing, and by mistake you have swapped it, that instead of sensor A you put in the sensor B slot, and sensor B you have put in the sensor A slot. So it's known as the cable swapped. Sometimes there can be a mistake in this, and also sometimes what happens, that a sensor is mounted in the opposite direction, right? Let's say one sensor you have mounted in the horizontal towards the north, and another one you have mounted towards the south, right? So what will happen, that these things are very important, especially the orientation, because these things create a lot of difference, right? Especially there will be a phase reversal. Let's say you have changed the direction of the sensor. What will happen? The sensor phase will be reversal, and instead of 0 degree, what will happen? You will see that a 180 degree. Then what you will say, 180 degree, there is some kind of a phase difference between these two locations. But actually there is no phase difference between these two locations, but by mistake you have put the wrong orientation. The position of the sensors are not correct, right? I hope the things are very clear. So it's very important to have the sensor orientation. Always you should keep the sensors in the same orientation. Okay, so always important that you should check the sensor direction before trusting any kind of phase numbers. So let's discuss the another common confusion. It's known as the phase wraparound. What is this phase wraparound? So let's say that one sensor is one side phase is 355 degree, or let's say 359 degree, and another one it's reading that you are getting the another sensor is let's say 3 degree, 1 degree, 2 degree, or something like this. So what do you think? Okay, there is a huge difference of around 360 degree, but always remember it's not the difference of 360 degree, because whenever we are measuring the phase, it's reality, it's a circular, right? It's not linear, right? So after 360 degree, again it will start from 1 degree. So always remember that if you are getting one reading around 358, another reading around 1 degree, that means it's okay. It's almost similar. It's not that your face is jumping from 1 to 358 degree. So it's very similar, because after 360 degree again you will start from 1 degree. So always remember this thing, right? Sometimes people have confusion in this. So now since we know that the phase is very powerful, but not always reliable. Why it's not reliable? Why? Because when we should not trust the phase? We should not trust the phase. That one thing that we have discussed in few minutes before, that speed should be always same, or the frequency should always be same. And so we should not trust the phase when, let's say, the speed is unstable, or there is a load is unstable, or let's say the amplitude of the signal is very low. Phase is continuously jumping. Let's say any bolt or any looseness issues there, and phase is continuously jumping like from 90 degree to 150 degree. So in that case we will not trust this phase readings, right? So in such cases what will happen? The phase will become unstable, and definitely it will mislead you or misguide you. So always remember, stable machines means stable phase, or unstable machine means unstable phase. Okay, so in real troubleshooting, what we will do normally, first we will be confirming that whether the speed and loads are stable or not. Okay, then what we'll do, we will check the time waveforms. Okay, or you can say the waveform or time waveform, same thing is there. Then we'll be looking after the FFTs or the spectrums. Okay, and finally then in the last, then we will be using the phase to confirm the fault. So this is the proper sequence if you are going for a real troubleshooting. So what will be there? First thing, the speed or the frequency should be same. Second, you should check the waveform should be perfect. Then you should check the spectrum should be perfect, right? And finally then you will start the phase measurement, right? And after that you can come to any kind of a conclusion, or any kind of a diagnosis, right? So to summarize this overall video, what we have learned here, that phase can be measured without a tacho, definitely, right? And phase is a waveform. What is the phase? Phase is a waveform timing. What is the phase? Remember this thing, phase is a waveform timing and always measured in degrees. And second thing, what matters to this is sensor orientation is very important, right? And what is the phase wraparound? That is also we understand it's very normal. If you see 359 or 2 degree, 3 degree, it's very normal, because it's a circular. Phase is like a circular, right? It's not a linear. And the last that we have learned is this, that phase should not be trusted when signals are unstable. So this was our third video, and I will also try to create one more video so that everything we can cover related to the phase. And so in the next video I will try to cover little bit phase behavior for different faults in more depth. And also we'll be seeing what is this the phase cancellation, what is this phase cancellation, and how we are using this phase shift in the resonance, and all the stuff that we are going to look on in our next video. Next video will be the last video for this phase analysis series, right? So now there is the last and interesting thing, that is the challenge that I normally used to give every time. So the first question is, can relative phase, please listen carefully, can relative phase be measured without a tacho? Okay, so the first question, can relative phase be measured without a tacho? Second, is 359 degree is very different from 1 degree? Okay, is 359 degree is very different from 1 degree? And the third, when should phase not be trusted? Okay, so total 3 questions. Please drop down your answers in the comment section. Till then, take care, and we'll meet you in the next video. The next video will be the 4th video for this phase series, and that will be the last video for this phase analysis. Then we'll move to the next topic in the vibration analysis. Till then, please take care and bye, and we'll meet you in the next video.